Hello and welcome to my CMSE 201 final project. I'm Noah Morrison, and today we'll be investigating the odds of Michigan being destroyed by a meteor. First, let's investigate what a meteor is. So, a meteor is typically any sort of space debris or rocks that come out of the asteroid belt, most commonly, and pass through the Earth's atmosphere and burn up. NASA's Center for Near-Earth Object Studies, or CNEOS, defines meteors more specifically as fireballs and bolides, which are astronomically bright meteors, so things that we can see passing through the atmosphere, such as shooting stars. The data we'll be using today is a chronological survey of the recordings of the peak brightness, date and time, the latitude, longitude, altitude, velocity, specific velocity vectors, and the total radiated energy and impact energy of meteors since 1988. Here's a heat map I generated using Google Maps API, which shows some of the largest meteor impacts, as including the Chelyabinsk meteor in Russia, which touched down just a few years ago, and was the largest recorded in human history. So I had to do some initial data processing to get the latitude and longitude points to where we want, because we're going to be analyzing what are Michigan's chances of being hit by a meteor. So currently they're in degrees, but we want them in more GPS coordinates, which means north is positive, as well as east, and negative is south and west. So we did that using some clever math and reading the data values. So there we have our translated coordinates. So then we take a scatter plot of all the fireball events, and using the sort of rough max longitude, minimum longitude, and max latitude, minimum latitude of Michigan to get this rectangular area, we can have an area estimate of Michigan. Now this is just a model, so it's not perfect, but we have this sort of square Michigan, and we're going to be investigating the probability a meteor hits that square on the map. And this can be done with any latitude and longitude. So we'll have the probability of impacts, but then what function do we use to estimate the probability of something seemingly so random? So you can see on the map also there in my plot the latitude and longitude bands that we'll be calculating the probability for. So here's some statistical processing. We have a histogram of all of the meteor impacts separated by latitude chunks. So you sort of get this grid shape on the actual map, and you can see where meteors have hit. So we have bins, so every 20 degrees of latitude, we're separating out the amount of meteors that hit, and that just gave a pretty nice value for the data we're working with. And we're doing something called a kernel distribution estimate. So you get this sort of probability distribution function, it's shown in orange on the curves there, that estimates the probability of being in any one of those bins for a random fireball event. You can see on the longitude side that it's not quite perfect. It's kind of linear, actually, and that's due to there not being a lot of influence on longitude to the actual fireball events. And we'll get into that in a second. So the Gaussian curve evaluation, so the given points for Michigan are plugged into the KDE, and then we get the probability values. And then we're going to take both probabilities for the bands, so the latitude and longitude bands, and then we will multiply them together, and you'll get the total probability you land in that square area. So here's the interesting sidebar. I actually ended up replicating a study that already existed when I was doing some further research from the University of Manchester in 2020, which showed that meteors are more likely to hit the equator. We used similar data, and I found the same result as they did, so I replicated something. And you can see this bell curve shape that shows that at the sort of 0 latitude mark, so that's the equator, it's more likely to be hit. And that's because the asteroid belt and the sun are in the same plane as the Earth, so things hit on the sort of asteroid belt sun line, which is the equator. So that's from Paul Kodis, the CNOS director. So some of my results, we found the chances for latitude and longitude, multiplied them together to find the total chance of the area, and found that Michigan has a 0.099% chance of being struck by any singular meteor event that is going to hit Earth. So if a meteor is already on the trajectory with Earth, based on previous data, Michigan has this almost 0.1% chance of being hit. Which is to say, maybe we'll be hit. I wouldn't count on it, but it's not something to bet with. So thank you, and keep looking up.